Okay, so it says the graph of a quadratic function is called a parabola. We already know this. It has a base function of y equals x squared. We have talked about the fact that the domain is talking about what can x be, and this parabola is going to keep getting wider and wider and wider in both directions. And when that happens, your domain is all real numbers, or you could say from negative infinity to positive infinity, right? All real numbers. The range is what can y be. And when we talk about range, we start at the bottom of the graph and we move up and we look for the first y that we have. And it looks to me like the first time we have a y is right here on the x-axis. We have a value for y right here. If we start at the bottom and go up, and y is equal to 0 right there. So our range would be, it could be equal to 0. So it's getting a bracket to infinity. Okay. They could also write it like all y's such that y is greater than or equal to 0. That's another way they would write it. Okay, questions about that? Okay, so a lot of this quadratic stuff that we're fixing to talk about has to do with those translations that we were talking about the other day, where we would move something to the left, to the right, up or down, and stretch it or shrink it or flip it across the x-axis. Okay, and then we're going to talk about how to kind of get the rest of this when you don't have it in this form. So if your equation is really nice for your quadratic and it looks like this, which I would say in life or in the real world that happens, maybe if it's already like that, it happens like maybe 2% of the time. Most people are not going to have a problem that is written in this form. We've already worked with several quadratics already, and most of them are ax squared plus bx plus c. They're not like a parentheses x minus h squared plus k. So, but if it's in this form, it's really easy to pick out some things about the graph. One of the things that it's easy to pick out is if the number a, which is in the front, is bigger than 0, then your parabola is going to be facing up. We already know this because if it's negative, if you put a negative sign, it's reflected across the x-axis, so it would be making a sad face and facing down if it's less than 0. Okay, this point, HK, is the vertex. So right here it says negative h minus h, so it will be the opposite of whatever this is, and k, and we'll talk about this some more in just a minute. X equals h, and so what is a vertex? I'm going too fast. What's a vertex? It's either the very bottom, right? It's either the very lowest the parabola could ever be, which is the minimum, or if it's turned upside down and makes a sad face, it's going to be the maximum. That's what the vertex is. Okay, then it says x equals h is the axis of symmetry. So this little line right here, they've got it dotted, but this little line right here, axis of symmetry means just exactly what it says. On that line, I could fold it and it would be the same on both sides. So that's what the axis of symmetry is. And whatever the x coordinate is, the h, that's how you would write your equation. We'll talk about that some more in a minute. I don't expect you guys to get all of this right now. K is the minimum value if a is greater than 0, and k is the maximum value if a is less than 0. Okay, so in standard form, which is usually, if you guys agree with me, that's usually what we see. We can't tell as much about the graph. We have to do a little bit of work but it's not hard work. We just have to do a little bit of work to kind of tell what things are if it's in standard form. We do know if it's a is positive, it's opening up, it makes a smiley face, and if a is negative, it's opening down, makes a sad face. And we can find the vertex by doing negative b over 2a. Okay, so from there, we can find everything else out we need. So when we're looking at this graph, you can see that this is in the form, it's going to write it right above it. F of X is equal to A times X plus H squared. Think that it needs to be minus, sorry. Minus H squared plus K. Okay, and that was just that formula that it was on the previous page that we're kind of comparing it to. So if it is in that form, one thing we know is that because A is positive, it's facing up, makes a smiley face. We know that. We know that the point HK is supposed to be the vertex. So H in this problem, now you got to pay attention that this is a minus here. So this says minus H. So we're looking at this. So we really want the opposite of H to get to H. So if H is plus 3, over here it would be minus 3. If we're going from the equation, does that make sense? So if this is a minus H, to get to just H, we would want to have, we'd have to do the opposite of that. And it's going to be negative 3. And then K is positive. So this whole thing wouldn't change. It would be negative 2. So inside the parentheses, we would do the opposite, which we're kind of already used to thinking that way, right? If it's inside the parentheses, if it's a plus 3, you're going to write down minus 3. But outside the parentheses, it's the same. And when we can see that, they already have this plotted. Negative 3, negative 2 is our vertex. It's the lowest point. Okay, the axis of symmetry is supposed to be X is equal to H. Well, in our case, we would say X is equal to whatever we got right here is supposed to go right here. It's not a trick. So negative 3, if we draw a line on X is equal to negative 3, if we fold it on both sides, it would be the same. Okay. If you look at this, you can tell it's either the lowest point, the vertex is either the lowest point or the highest points that are going to be on this graph. And it is definitely the lowest. So we would have a minimum, and our minimum is the point negative 3, negative 2. Right? Anybody confused by that? This graph is, just want to go ahead and talk about this real quick. This graph is decreasing. So if we go from left, you always want to go from left to right when you're talking about your graph. So the first thing that I get when I'm talking about my graph and I come to it, it's decreasing, it starts going down. So it's decreasing from negative infinity all the way to, what is X? You always want to talk about increasing and decreasing in terms of X. What is X right here? Negative 3. And I'm putting the bracket there because that's where we kind of experience a change. And then it's increasing from negative 3. Hold on. I think we need a parentheses there because it's not equal to that. It's just, that's where we kind of stop. And then it's increasing from negative 3 to infinity. From where X is equal to negative 3 all the way to infinity, this thing's going to keep increasing. Are you guys okay with that? All right, because we're going to talk about that some more in just a minute. So this one is definitely written A times X minus H squared plus K. The vertex is supposed to be the point, HK. H is always going to be opposite of whatever it is here. So if it says minus 1, you're going to put 1. It's inside the parentheses, you put the opposite of whatever it is. K is plus 3, so it's just 3. And you can look at the graph and verify, okay, well, that's the highest point. That is the vertex. We got it correct. The axis of symmetry is supposed to be X is equal to H. This is not a trick. So whatever you got for this, the equation is supposed to be X equals 1. That's the line, X equals 1, where you would fold it, where it's the same on both sides. Does this have a minimum or a maximum? It has a highest point, so that's a maximum. And our maximum is always whatever K is here. So it does have a maximum point, and the maximum point is 1, 3, but is also 3, right? It never gets higher than 3. So when you refer to that, you kind of think about, well, why does it get any higher than 3? That's your maximum. This is the specific point it happens at. Does that make sense? So if we talk about increasing, this needs to say increasing. So if we talk about increasing and decreasing, you always want to start from the left and go to the right. So if I start at the left, I'm going up first, right? So it's going to increase from negative infinity all the way to, always talking about what X is. What is X right here? To 1, and it's decreasing from when X is 1 all the way to infinity. That is confusing to some people because they want to make it about the Y point. When you're talking about increasing and decreasing, you're talking about, you always look and see what X is at that point. Questions about that? Okay, so here we go. This one is a little bit more challenging just because it's not in that form, AX plus H, all that stuff. So we have a standard form. This form is f of X is equal to AX squared plus BX plus C. Okay. So to find the vertex, the calculator, I'm going to show you in a minute how the calculator kind of helps with this. But the math is really easy to do on this. So some of you may just choose to do the math and maybe check yourself on the calculator. So to find the vertex, well, the first thing I would do is I would go to my axis of symmetry because that's the easiest way to find my vertex. So to find your axis of symmetry, X is going to equal negative B over 2 times A. And that's just a fraction. That's not going to be hard to find. What is B in this case? 10, right? B is where the 10 is. So we would say negative 10 over 2, and A, we've got 1x squared. So A would be 1. You guys should be really good at picking out this A, B, and C stuff because we've done it a whole lot. Even if you were using your calculator, you're good at picking out A, B, and C, right? So that's negative 10 divided by 2. So negative 5. So our axis of symmetry is X is equal to negative 5. So always the vertex occurs on that axis of symmetry. So if I go and do this second part and say, well, I need to find my vertex, I need to figure out, well, what is this equal to when X is negative 5? So I'm going to my equation. Instead of X, I'm plugging in negative 5. Okay, and I would come up with the answer to that. So we've got 25 minus 50 plus 23. So negative 2. I'm going to check myself because make sure we're not messing something up. Yep, negative 2. So my vertex happens, this would be the answer to Y. So my vertex happens when X is negative 5 and Y is negative 2. So I know that. I can go plot that point, negative 5, negative 2. Okay, is this graph going to open up or down? We should know that from looking at A, if A, the number in front of X squared, is positive or negative. Okay, it's positive, so that means it's happy, so it opens up. Okay, A is positive, it's just a 1, so it definitely opens up. And if it opens up, it looks like this. Sometimes this helps students to kind of just draw the smiley face. Is this one gonna have a minimum or a maximum? It's gonna have a minimum because There's going to be no point that's lower than that. Okay, how can I get some points on the graph? I can use the calculator, or I could plug in some things for X and find some Y's. It doesn't matter, but we're kind of used to using the calculator and we're fixing to use it to check our answer anyway. So let's go there and type in our equation. So I would go to Y equals, get out of here, X squared plus 10X plus 23. If you aren't doing this right now, please do this, because in a minute, you're going to want to know how to check some of your stuff that we just found. And if you've already typed this in, it'll make your life easier. Okay. Now I can look at my graph. We said -5, -2 was the minimum. So we kind of want to pick on our table. We want to pick points on both sides of -5. So when I go second table, -2.7 would probably be good, but I need something on the other side of -5. So maybe -2.7 and -8.7, because those would be on both sides of -5. So I think we said -2.7 and -8.7. Those aren't the only 2 points you could pick, but those would be on our graph. And we know that this makes kind of a U, not a V. So you want it to actually look like a U. I know that's not perfect, but okay. What about any questions so far? What about domain? What can X be? All real numbers from -infinity to +infinity, because this thing gets wider and wider and wider. What about range? We look at our graph, and it looks like we go from the bottom up. The first Y value we come to is -2. So it can be -2 all the way to infinity. Another way to write that would be all Y's such that Y is greater than or equal to -2. Are we okay with that? Okay, increasing interval. Well, so you always want to start from the left and go to the right. So does this thing increase or decrease first? Okay, think about reading a book. Go from, because this is so confusing to people. If you're reading a book, you're reading from left to right. Don't make up your own rules here, okay? When you're reading a book, you're going from left to right. So if I'm reading a book and I'm on a roller coaster, I'm going down first, right? So we're decreasing first. So that means that we're decreasing from, we're coming from the -infinity side. I don't know why standing up affects my writing abilities, but so we're coming from the -infinity side, and we're decreasing all the way down to here. And remember that you're always referring to what X is when you're talking about decreasing and increasing. So what is X right here? -5. But then at -5, going back up on the roller coaster, and I'm increasing from -5 all the way to infinity forever, okay? Questions about that? Okay, so before we turn the page, what was I talking about on this calculator thing? So remember that we went to our calculator, we typed in, we went to Y equals, we typed in this stuff. Okay, you can check some of this stuff on your calculator by doing second, and then right above the word trace, which is one of the top buttons, it says calc. So I can hit second trace, and then it'll calculate some of these things for me. It'll tell me my minimum or my maximum. It'll tell me my zeros, which is where it crosses the x-axis or x-intercepts. Okay, so on this one, remember it had a minimum. So that would be a good one to make sure that we're kind of on the right track. So we had a minimum value, so I'm gonna go down there to calculate it, and I'm gonna hit enter. Then it says this crazy stuff about left bound. So what we want to do is we want to find our cursor. Right now, my cursor is way away from anywhere on here, but I want to pick something to the left of this point because I know this is my minimal. So I'm going to kind of use my arrows because I cannot even see my cursor. It's telling me my cursor is over here at x equals 1.5. So that means I need to go back because it's way on the other side. There it goes. This tells you where your cursor is located on the x-axis. So I'm kind of backing up. So if I want to pick something to the left of my minimum, I just need to have something to the left of this point. This is, so I would hit enter. Then it says, wait a minute, I want something to the right of it. So I'm going to go use my arrows to kind of pick something to the right of this point. I'm going to hit enter. Do I want it to guess? Yes, because that means tell me the answer. I'll hit enter, and it says -5, -2. Do you see this point one, this one way out here? Some of you may get some weird something like that sometimes. And if you get that, you just kind of need to ignore it because this calculate, it's a computer and it's not working the problem like we would, I guess. So -5, -2. So we did a good job when we found it, but that would also tell, verify that we did a good job. Okay. Questions about that stuff? We'll come back and do the next one on the calculator in just a minute. So let's look at this. So we don't have a graph on this one. It's just asking us to solve it. Find the stuff about it. This one is definitely f of x is equal to ax squared plus bx plus c. Okay, it's in that standard form. First thing I'm going to ask you is A in this case negative or positive? It's negative, right? A is -1 because x is -x squared. So if A is negative, it is sad. It is facing down. That's one thing I know. And if it's facing, so it opens down. And if it opens down, does it have a minimal or a maximum value? It has a maximum value. I'm gonna go ahead and take care of that because that helps me kind of wrap my mind around what I'm doing. Okay, to find the vertex, the first thing I would suggest you to do is not find the vertex, find the axis of symmetry. If you're going to do this by hand, so the axis of symmetry is located at x equals -b over 2a. So b in this case is 14. So I want to put -14 here. A in this case is -1. So this would be 2 times -1. So -14 divided by -2 is 7. So my axis of symmetry is x equals 7. Anybody lost? So if I draw this line right through here, this line should be x equals 7. Okay. So what I know about my vertex now is that my vertex, the x part of it is going to be 7. I need to find the y part of it. To find the y part of it, all I have to do is plug in 7 right here. So -7 squared plus 14 times 7 minus 47. Okay, so I would type that in my calculator or in my brain. I'm not going to try to do 14 times 7 right now. Probably not even that hard to do, but. Okay, I'm getting 2. So that is what would go right here. So my vertex is at the 0.72. Okay, this is not asking for other points on the graph, but because we're not having to graph it, but if I needed other points on the graph, I would want to pick some things that are kind of less than 7 and some things that are bigger than x equals 7 so I could get on both sides of that. This one did have a maximum value. The maximum value happens when y is equal to what? This is the vertex right here. The vertex we just found was 7, 2. What's y right there? So my maximum happens when y is equal to 2. If I want to get really specific, it happens at this 0.72. But a lot of times they talk about it in terms of y. What about my range? If we start at the bottom and we go up on this graph, so I mean, this is going to go down forever, right? So my range would be from negative infinity all the way up to, what is y right there? Doesn't get any higher than 2. Okay. We talk about on what intervals is this function increasing? Well, we're going to go like we're reading a book. So we're going from the left to the right. So it's increasing. It looks like we would start going up the roller coaster. So we're increasing from negative infinity all the way to right here. And you always talk about what x is when it's talking about increasing or decreasing. And x is 7. It's decreasing from 7 all the way to positive infinity. We're going to go down. Questions about that? Please remember this whenever you're doing the increasing and decreasing. It has to do with what is x, because it logically in our minds, when we're talking about increasing and decreasing, going up and down, we're looking at the y-axis, because the y-axis is the part that goes up and down. Okay, but you got to compare it to the x-axis. What's happening with x? Okay, here's our application problem. It says a model rocket is launched with an initial velocity of 100 feet per second, which is where this 100 came from the top of a hill that is 20 feet high. So there's our starting point. We start out at 20 feet. Its height in feet, t seconds after it has been launched, is given by this function. What does this negative 16 represent? I know you guys had tons of this in high school. So what is the negative 16 talking about there? If we launch something, it goes up, and then what has to happen to it? And what makes it come down? Gravity, right? So this is your number that's representing your gravity that's pulling it down. Okay, that negative 16. So it says determine the time at which the rocket reaches its maximum height and find the maximum height. Okay, just draw you a little picture. You don't need the whole graph here. If you're looking for the maximum height, what is that? What is another word we call this point up here at the top? We call it the vertex. I think I heard you guys say that. If we can find that vertex, then another thing we need to know is, okay, that vertex would give us a point x, y. In this problem, what's the x talking about? Because the x goes from here to here, right? What's x talking about? Our x is a t. So t is in seconds. So this part of the graph is talking about seconds. And then, I don't know, it's going to be somewhere over here. What's your y part talking about? So this is our t. When we find this, it says that this function, its height in feet, t seconds, says after it has been launched. So this is talking about s sub t is our y. That's our height. So what we're actually looking for, this is important. You got to decide which one you're looking for, x or t. And it says determine the time. So we want to know what x is right here, at which the rocket reaches its maximum height, and then find the maximum height, which would be the y value. Okay. So we need to do, I'm going to come down here to kind of do, we need to do this x equals negative b over 2a. We need to do that. And we're going to use our calculator to kind of check our work in a minute, but I need to find negative b over 2a. So this would be ax squared plus bx plus c. So negative b would be negative 100 over 2 times a, and a in this case is 16. So negative 100 divided by negative 32. I'm getting 3.125. So already I know that the maximum time is 3.125 seconds because I know that X is talking about the time. To find the Y value, all I need to do is go to my formula and plug in my 3.125 every time I see a T. Okay, that will give me the answer to, well, how high was this thing at the maximum or at the vertex, the maximum height? I'm getting 176.25 and it says it's in feet. Okay, and I'm going to show you this problem on the calculator, and this is going to verify for you that you probably want to make sure that you can do this without the calculator. This is not hard to do without the calculator. You find negative b over 2a, you plug it in. Okay. Because when I go to my calculator, it's very possible that I can verify my answer, but for some of you, you're going to struggle with this because most of your graphs go from -10 to +10. And we've got to have a graph that goes all the way up to 176 point something, right? So I'm going to go to y equals, and I'm going to plug in my I'm going to type in -16x squared plus 100x and then plus 20. Okay, and I'm going to hit enter and I'm going to hit graph. And I already knew it was going to be a problem, right? It doesn't show. Okay, and so I can go and mess with my window and I know that my Y value is going to be at least, I'm going to make it 200 because I know the answer is 176. Okay, so I'm going to hit graph now. I can see it. You probably had some teachers that also told you to use this zoom button. If you use a graphing calculator in high school, you can hit zoom 9 and that will help with that too, other than changing your window. But this is why you want to kind of know how to do it by hand. So I can, from this point, go second calc. I know I have a maximum value I'm looking for. I can pick a point on the left of this maximum, hit enter. I can go around, pick a point on the right, hit enter. Yes, I want it to guess. So hit enter and it tells me it's it's not perfect, but 3.1249, 176.25. So I got it right. The problem is going to be just being able to work your calculator to get it to give you what you want and be able to see that peak. So if you're able to do that, for sure, check yourself or do it that way to start out with. If you're not able to do that, I'll be more than happy to help you figure out how to do that. I don't mind at all, but I would make sure I know how to do this one by hand too, just to make sure you're safe if you're taking a test or something. Okay. That's the end of this section. Really quick,